Imagine a place in the ocean where ships avoid going, where divers feel a strange pull, and where anything that enters never comes back the same. This is not a myth. This is not a movie. There exists a massive hole in the ocean, so deep, so mysterious, that scientists are still trying to understand what really happens inside it. Some say it's just a natural formation. Others believe it hides something far more terrifying. But what if I told you this ocean hole can literally swallow everything that comes near it? Today, we're diving deep into one of the most mysterious places on Earth, and trust me, what you're about to see will change how you look at the ocean forever. Welcome to Curiosity Rift.
Look at this aerial photograph. You're seeing a massive, perfectly circular black pupil staring up from the center of a shallow turquoise reef. It is an abrupt drop-off from vibrant coral to an absolute void. That black pupil is a blue hole, a vertical cavern or sinkhole carved straight down into the ocean floor's carbonate bedrock. Some of these underwater pits plunge hundreds of feet into the darkness. To understand how they got there, we have to rewind to the Pleistocene epoch, the geological time period encompassing the last major ice ages. Back then, global sea levels were roughly 400 feet lower than they are today. This diagram illustrates what the area looked like during that ice age. Instead of an ocean, this was a massive, dry limestone plateau. Rainwater and slightly acidic groundwater percolated down through open faults in the rock. Over thousands of years, that acidic water dissolved the limestone, hollowing out an enormous network of dry, subterranean tunnels and chambers. If we watch this same cross-section over time, the ice caps eventually melt, the global sea level rises rapidly, flooding those caverns from below and completely swallowing the plateau to create the submerged structure we see today. Blue holes function as drowned time capsules, preserving the specific geological footprint of an ancient, dry Earth within the modern ocean floor. Descending into one of these sinkholes introduces immediate physical challenges. For every 33 feet a diver drops, the water pressure increases by 1 full atmosphere, steadily compressing the air in their tanks and their lungs. Look closely at this photograph of divers navigating the deep. Massive limestone formations line the cavern walls, completely submerged in seawater. These rock formations, speleothems, like stalactites and stalagmites, confirm this space was once entirely dry. Because they can only form through the slow dripping of mineral-rich water in open air, their presence hundreds of feet below the surface records a time when the ocean had retreated completely. As divers continue downward, they hit the chemocline. This is a sharp boundary layer in the water column where the chemical makeup of the ocean shifts abruptly into a lethal state. This diagram shows the distinct layers inside a blue hole. Between the freshwater lens and deep ocean water sits a thick band of hydrogen sulfide. This toxic cloud blocks sunlight. Beneath it is anoxic seawater, a stagnant zone with zero oxygen, where biological decay pauses. Without oxygen-dependent bacteria to break things down, the bottom of the cavern becomes a site of perfect preservation. Everything that falls through the sulfide cloud, from ancient conch shells to extinct animal bones and even human remains, sits untouched by the passage of time. The deep water functions as a graveyard for surface life, but it simultaneously serves as a cradle for specialized extremophiles, organisms adapted to thrive in the harshest environments on Earth. Because sunlight never reaches this depth, these microbes survive through chemosynthesis. Instead of using solar energy to make food, certain bacteria, like the genus Thiomicrorhabdus, a group of sulfur-oxidizing microorganisms, derive their energy directly from the toxic chemical reactions of the hydrogen sulfide itself. Bacteria aren't the only things living down here. The top predator in this entirely sunless ecosystem is the Bahamian blind cavefish, a species scientifically known as Lucifuga speleotes. Confined entirely to the dark recesses of these caves, this fish has adapted to the point where it completely lost both its functional eyes and its skin pigmentation over generations of isolation. To hunt in a pitch-black, toxic environment, the fish relies on an advanced array of neuromasts. These are specialized sensory organs running along its body that can detect the microscopic water vibrations created by the movement of its prey. It is an entirely separate path of evolution, taking place quietly beneath the ocean floor. Life here has mastered survival in a chemical bath that is instantly lethal to almost every other creature on the planet. This animation illustrates a major physical hazard, tidal pumping. Because blue holes connect to the open ocean through subterranean conduits, rising and falling tides turn the cavern into a giant oscillating lung, sucking millions of gallons of water into dark tunnels. Another constant danger is a silt-out. A diver's hand lightly brushing a limestone ledge triggers an explosion of fine sediment. The cloud billows into the water, dropping visibility to absolute zero in a matter of seconds. Add to that the psychological and physical toll of swimming through the hydrogen sulfide barrier itself. This layer is so chemically aggressive, it causes acute skin irritation and severe dizziness for anyone passing through it. Given the crushing pressure, the toxic clouds, and the sudden currents, it raises a simple question: why do researchers risk their lives to map these flooded caves? Look at this photograph from a NASA presentation regarding the search for life in the universe. The extreme conditions inside a blue hole serve as perfect astrobiological analogs for the subsurface oceans of icy moons, like Jupiter's Europa or Saturn's Enceladus. By studying how extremophile bacteria process sulfur and thrive in the pitch-black, anoxic depths of the Bahamas or the South China Sea, NASA can build accurate biological models for how life might persist in the dark, high-pressure oceans beyond Earth. These sunken caves preserve the ancient geological memory of our world, while the resilient ecosystems trapped inside provide a blueprint for understanding where life might hide in the cosmos.
So now you know the truth behind the ocean hole that seems to swallow everything. But here's the real question. Is it just nature? Or are we still missing something deeper? Something we haven't discovered yet? Let me know what you think in the comments. Would you ever go near a place like this? If this video made you curious or even a little uncomfortable, make sure to like the video and subscribe to Curiosity Rift for more mysteries like this. Because the ocean isn't just deep, it's full of secrets we've barely scratched. And this is just the beginning.